Leetcode problem 13, Roman to integer. First, let's go into the problem description. Numerals are represented by 7 different symbols. Here, the symbols and its respective values are mentioned. That means I indicates value 1, 5 indicates value 5, X indicates value 10, L indicates value 50. So, likewise, the other letters and values. Okay, now let's see example. For example, 2 is written as I. That means it indicates 1 plus 1. In Roman numeral, it is written as 2 i's and just two ones are added together, and 12 is written as x2 x11. Simply we can evaluate like this from right to left, that is 1 plus 1 plus 10. 1 plus 1 plus 10, which simply indicates 10 plus 2. Similarly, the other numbers like 27. Roman numerals are usually largest to smallest from left to right. However, the numeral 4 is not 4 i's. Instead, the 4 is written as I, comma, I and V, because the one before the 5 which we subtract making 4, same it applies for 6 and same it applies for 9. Let's go into this. uh, See, when we from right to left, when we observed a letter which is lesser value than the previous one, it has to be subtracted. It is the main rule in Roman. That means if we observe I, which means 1, before 5, which means 5, it makes it as 4. Okay? And I before 10, which makes it as 9. And similarly, 10 before 50 makes it as 40. From left to right, I'm telling about left to right. And 10 before 100 makes it as 90. So let's go into the example 1. So if we consider 1 I, if we consider as I, which means let's first iterate from, let's consider a point from right to left, right to left. Okay, the value here is 1. So from for answer we are adding 1. Now the pointer moves to the next point, next index. The value from the map we can get it as 1. So we can add it as 1. And for the next index, we can next the pointer moves to the next index. The value for I is 1. So we can add the answer for 1. That means 3. We can return the answer 3. That's how it works. What if we have number 4? In Roman, it is indicated as 4, right? That means if we observe a pattern, like let us consider number 9, it is 1x. Let us consider number 6, it is, let us consider 11, it is represented as x and I. If similarly the other numbers, if we observe a pattern here, the bigger number which is present at the right end, which is greater than the number which is present at the left end, like this value indicates 1, this value indicates 5. So we have to subtract 5 minus 1. That's how it works to get the Roman integers. So when we encountered a value which is bigger than the previous one, we have to append the value to the answer. If it is smaller than the previous one, like this case, in this similar case, that means here the value is 10, but the left side value is 1, which is lesser than the previous one. We have to subtract it from the previous number, like 10 minus 1, it results 9. That's how it works. So let us consider one example from the let us consider one example here. So example number 2, that is LVII. Here let us consider a current pointer which indicates the current pointer, and previous pointer which indicates the previous number, just to get the previous number is great, similar to this case, to check whether the previous number is greater than the current number or not. And let's consider the answer which we have to return. So let us first assign this first index to the previous number. So that means it is I, which is equal to, in map we can see, which is equal to 1, right? So sorry, my bad. In previous we have to assign 1. So this is the first pointer. Now let's assign 2. Now let's go to the next index. Now the value which is pointed to the pointer is less than or equal to the previous one. So now we can add it to the now first consider the pointer, first update the pointer to the current value. Here the current and previous are equal, so we can add it to the answer. Now the pointer points to the next index. Now the current value is updated to 1, and previous value is updated to 1. Now the previous and the current values are equal, so we can append it to the answer. Now the pointer next points to the next index. Here v. Now let's check it. The v value is 5. So v value is 5 from the map we can get it. The current value is 5. Previous value is 1, which means the current value is greater than the previous one, so we don't have to handle this case. We can simply append the answer. Sorry, I missed the previous one. So simply we can append the answer, which is 5. Now we have to update the previous to 5, and the current value points to the pointer to the next index, and the current value is L, which means 50. So 50 means which is greater than the previous one, so we simply add it. Now the result answer is 1 plus 1 2, 2 plus 1 3, 3 plus 5 8, 8 plus 10 5, 8 plus 50, it's 58. So now we got the correct output. Okay, now let's handle a case which has the exception like this. If we point the previous value is bigger than the current value, so which is nothing but we have to subtract it from the current answer, right? So let's take the example 3. Here the input is m, c, m, x, c, I, and v. So what are the pointers we are considering? The previous one, the current one, and the answer, right? Sorry. So Let's start the approach. First, we are going to initialize the previous to the 0th index, which means v. From the map, we can get it as v means 5. So we can assign 5, and we have to calculate the answer, right? So 5 is added to the answer. Next, let the if when we next point now the pointer points to the next index. That means I means 1. The current value is 1. Now let us compare the previous and current value. Now the current value is lesser than the previous value, so we have to subtract the current value with the answer. So which is the approach I have discussed before, the exception in the Roman integers. So now we have to update the current value with the previous value, that means 1 here. Now the pointer points to C, that means the next index, which means C value indicates 100. Now the current value is 100. If we look into it, the now the answer is 4, right? If we evaluate the answer, so if we compare the current value with the previous value, now current is greater than the previous, right? So we have to add the answer, right? That means 104. Now the pointer points to 10. Sorry, we have to miss I have missed this one. I have to update the previous to the current value. Now the current pointer points to the x, which means value 10. Now we have to update the current value. That means if we compare it, 10 is lesser than 100, so that means current value is lesser than the previous one, so we have to subtract the current value, that means minus 10, which means 94, right? Now we have to update the previous value with the current one. Now the pointer points to the next index, that means m, which is equivalent to 1000. Now we have to update the current value 1000, which means the current value is greater than the previous one, so we have to add it, which results 1094. Now the current value points to the now we have to update the current value with the previous one. Now we have to update the previous value with the current value, sorry, which means 100. Previous is assigned to 100. Now the pointer points to C. The C value is 100. C value 100. Now the current pointer points to now the current value is 100, which means the exception case, which means the current value is lesser than the previous one, so we have to subtract 100, right? That means 994. Now we have to update the previous value with the current value, that means 100. So now the pointer points to m, which is equivalent to 1000. Now we are updating the current with 1000. Now let us now consider now we have to compare the previous value with current value, which is greater than the previous value. That means we have to add 1000. That means 1994. Okay, now we got this one 1994. Let's check. Yep, we got the desired output, expected output. That's how the logic works. Now let's implement this logic. Before solving the problem, let us create a hash map which we assign the I value to 1, and we have to retrieve the equivalent value for that character, right? So for the better purpose we use map data structure here, where the map data structure stores key value pair. So we are considering the character set as a key and values as a value, like sorry, integers as a value. So let's type the code. In Java we use hash map to store it. Here we are considering keys as a characters and values as integers. Sorry. For better representation, I'm using new hash map. Yeah. Now hash map is created, right? Now we have to update the hash map with the values. Let us append the values. Dot put character I means 1, right? And V means 5. Dot put X means 10. Likewise, others. Yeah, I have added the all the equivalent symbols with the respective values in the map. Now I have put them into the map. So let's start coding. So let us consider the previous pointer. Here I'm directly storing as integers for better comparison, and current pointer which stores the current character value, and one value which means answer, means like one we have to return, right? The summation of the entire value of the string in the integers, the decimal representation of the Roman value is stored in the answer. So, and one pointer I for the iteration of the string. Now we are iterating from right to left, right? So we have to initially append it to the value, to the last character of the string. So s dot length -1, because the index starts from 0, we have to write -1. That means here the string length is 3 and the pointer is 2, 0, 1, 2. So we have to write 3 minus 1. That's how it works in strings. The indexes starts from 0. Okay. What if we have a single character in the string? That means we don't have to compare, we don't have to do anything, right? So we directly return that value. Like if we have string like D, the value is 500, right? We don't have to consider anything, so we can directly get that value from the map. So return dot get, we use the get method to retrieve the value from map. We are retrieving what, like dot sorry s dot cat at 0. That means we have only single length string. We are directly returning it. Now let's start coding where the actual code is resided. The actual logic is written. Well, I greater than or equal to 0. That means, wait, let me explain. We have to iterate from here to here, right? Sorry, from this point to this point. That means we are initially assigning the previous value and considering from which is from index second from the end to the starting. That means 0, right? So first let's initialize previous to the last value. Let's simply write. We have already assigned the I value, right? So we can directly write it. And we have to append this value to the answer, right? So we have to update that value. We have to sum that value plus previous. And one pointer is evaluated. Now we have to decrement the pointer. Now let's start writing. First step here, initializing previous value is done. Now we have to get the current value. Current equal to hm dot get s dot cat at I. Now we got the current value and the previous value. Now we have to compare the current and previous value, whether we have to add or subtract. If current value is if the current value is greater than the previous one, we have to add it. Greater than, and in the first case, greater than or equal to. Even if it is equal also, we have to add to the answer. So greater than or equal to the previous value, we have to add to the answer. That means answer equal to answer plus current. And we have to update here. We have to update the current value to the previous one. We have to assign the current value to the previous one for the next pointer, right? So previous equal to current. Yeah. Now we have handled the basic one. Now we have to handle exception. That means the current value is less than the previous one. What we are doing, if the current value here in this case, if the current value is less than the previous one, we are subtracting the current. So from the answer, right? Not from the previous or current. We are subtracting the current value 10 with the answer we have updated, which is updated from the previous one. So answer equal to answer minus current. And even in this case, we are updating the previous with the current value, right? So the current value is updated, and now the previous value equal to current. We can skip this code and directly we can write previous equal to current here. And anyhow, we have to decrement the pointer to move to the next index, and we have to return the answer. It evaluates, and we got the actual answer. We can skip this step like this. We can directly mention just to reduce the lines. No problem. Let's check test cases. Oh, all the cases are correct. Now let's submit this answer. Yep, we got 4 milliseconds, which is not bad code, right? Thank you so much, and feel free to subscribe. If you have anything, please make sure to comment. Any doubt, I will reply to you. Thank you.